Hello students, welcome to Online Maths Classroom. Today we are going to take up part 3 of your topic integration, in which we will cover integration using trigonometric identities and the solutions of NCERT exercise 7.3 based on it. So let us start with it. Integration using trigonometric identities. When the integral involves some trigonometric functions, we use some known identities to find the integral as illustrated through the given following example. Okay, so when your function is involving trigonometric functions and we are not able to integrate the function using direct formula or the substitution as we did in our previous exercise 7.2, right? So we will search for the use of trigonometric identities if it is possible to put and then integrate the function. So let us see how to use this trigonometric identities. Now number one is your cos square x dx. This is an example. Similarly, sine square x will behave. Now to integrate cos square x, I will use that formula cos 2x is 2 cos square x minus 1. Okay, or cos square x is equal to 1 plus cos 2x upon 2, right? This one. Similarly, sine square x is your 1 minus cos 2x upon 2, right? So always whenever I have to integrate cos square x, I'll open it by using this formula. That half will come outside and it is 1 plus cos 2x. Now separate the integral half 1 dx plus half cos 2x dx. So this integral of 1 dx is x, so it becomes x by 2 plus it is, integral of cos 2x is your sine 2x divided by 2, right? So, and this 2 into 2, that will be your 1 by 4 plus c, because it is an indefinite integral. Then next is your sine 2x cos 3x. Now for it, I'll recall my identity sine x cos y, right? Because you can find that the angles are different here. So if I'm putting, say, sine 2x as t like previous exercise we have done, so it will not work out, right? Because I need the derivative also like cos 2x, okay? So here I will use this formula sine x cos y as half of sine x plus y plus sine x minus y, right? So what will I do is I'll multiply and divide by 2, right? I'll write it as like it is half into this 2, right? And then I will use the formula of my 2 sine a cos b, okay? 2 sine a cos b, which can be used like your formula of half, and it will become your sine x plus y and plus your, this is sine for plus sine of x minus y, okay? So x we are taking it as 3x and y we are taking as 2x, so that because in product you can interchange the terms and I don't want to involve my negative sign, so I'm taking x as 3x and y as 2x, okay? So that I'll get it as plus sine x. Now I can integrate it, it will become minus cos 5x upon 5, right? Because the integral of sine is minus cos, and it will become your plus cos x, okay? Plus cos x, and it is plus c, right? So it is your minus 1 by 10 cos 5x plus half cos x plus c. Number 3 is your integral of sine cube x. Like sine cube x, cos cube x will also behave in the same way. So we can do this integral in 2 ways. One is by using the formula of, say, sine 3x, which is 3 sine x minus 4 sine cube x, right? And from here I'll get the value of sine cube x, which is your, means take it to other side, means take this 4 sine cube x to this side and bring sine 3x to this side. So it becomes 3 sine x minus sine 3x by 4, right? So put the value like 3 by 4 sine x minus 1 by 4 sine 3x dx. So it becomes minus 3 by 4 cos x, right? Plus 1 by 12 cos 3x plus c. Or I can open sine cube x as sine square x into sine x dx. Now I'll open this one sine square as 1 minus cos square x, okay? And sine x dx. Now put this cos x as t, as we did in exercise 7.2. So cos x is t minus sine x dx equal to dt. So it becomes 1 minus t square, okay? And sine x dx is minus dt. So we took the negative sign outside. So it is 1 minus t square for this, and this complete is minus dt. So integrate, this becomes as minus t plus t square is t cube by 3 plus c, and re-put the values of t as cos x and you'll get the answer. Okay, so let us start with exercise 3. 7.3 is, your first question is sine square 2x plus 5. Now, whenever there is sine square, whether it is sine square x, sine square 3x, sine square 2x plus 5, like, always you have to use that formula where sine square theta is 1 minus cos 2 theta by 2. Okay, now see, my angle here is 2x plus 5, theta is 2x plus 5. So how will my formula change? It will be half of 1 minus cos of 2 theta, like 2 theta. Okay, dx. So it becomes 4x plus 10. Now integrated, it becomes half 1 dx minus integral cos 4x plus 10. So it is your x, 1 is x, and minus integral of cos is sine. It is not minus sine. So it becomes sine 4x plus 10, and you have to divide by d dx of 4x plus 10, that is 4. Right, plus c. Now open it, it becomes x by 2 minus 1 by 8 sine 4x plus 10 plus c. Second question is sine 3x cos 4x. So as we did in our example, multiply and divide by 2. Right, now what is the formula for 2 sine a cos b? Right, it is sine a plus b plus sine a minus b. You can remember by and that pattern we did in our last year, that is your s plus s is s plus s is 2 S C. Okay, 2SC, 2 sine cos. Similarly, S minus S is 2CS. Right, and similarly, we can go for C plus C and C minus C. So this formula in a reverse manner, it becomes as, so since it is 2 sine cos, so it will become, now take A as the bigger angle, B as the smaller angle. So it becomes sine A plus B plus sine, look here, sine A plus B plus sine A minus B. So it changes to sine 7x plus sine minus x, which can be taken as minus sine x. Okay, so integrate, it becomes minus cos 7x by 7, and it is your minus cos x. So minus minus is plus cos x, and multiply with half, and plus c is outside, and this is the answer. Question number 3 is integral cos 2x, cos 4x, cos 6x. Now here you can see that in the previous question there were only 2 terms. Here there are 3 terms. So in the same way I'll proceed, but I have to use that result twice. Okay, so firstly, out of these 3 I'll associate the 2's out of which I can take the thing like third as common. Okay, so see, if I'll take this cos 6x and cos 4x together, right, then the very first thing is to multiply and divide by 2, right? So that I will just focus on this part, because I'm going to apply, this is your C plus C. Okay, so C plus C, you very well know it is 2cc, right? So it will be resubstituted as, here it becomes half of cos C plus C, means it is cos A plus B, right? See from here, it's cos 6x plus 4x, and it is cos 6x minus 4x, and outside it is multiplied with cos 2x. Okay, so it becomes cos 10x plus cos 2x, and this cos 2x is there outside. Now open it, because you have to multiply with cos 2x also. So it is 1 by 4, right? So means it, you have to multiply with it also. So it becomes firstly your cos 10x into cos 2x plus cos square 2x. Now you know this cos 10x and cos 2x again needs this kind of substitution. So I'll again multiply and divide by 2. Okay, so it will become your 1 by 4, 2 cos 10x cos 2x plus 2 cos square 2x. Okay, because it was cos square 2x, so when you will multiply by 2, it will also be multiplied. So it becomes 1 by 4. Again I'll apply the same formula as your 2cc. So it is cos 10x plus 2x, that is 12x plus cot 8x, and this becomes your, the formula for 2 cos square 2x is 1 plus cos 4x. Okay, so now again you have to this has converted to this. Now I think each one of them can be integrated now directly. So the integral of cos 12x is sine 12x upon 12. Your integral of cos 8x is sine 8x upon 8, and cos 4x is sine 4x upon 4, and this one is integral is x plus c. Okay, so in this way this question can be integrated. Number 4 is your sine cube 2x plus 1. Now, to integrate sine cube x, we discussed that we can just change it to this form. The second way, like sine square and then sine. Angle is 2x plus 1, right? And the first sine square is need to be changed as 1 minus cos square. And the second one is your sine of 2x plus 1 dx, okay? Here it was multiplied and divided by 2, so it is not required to remember like this. You will just gain it when you will put cos 2x plus 1 as t. So it becomes minus sine 2x plus 1 dx equal to dt, right? So it becomes your integral becomes as minus half, right? And this is 1 minus t square dt, which can be integrated as t minus t cube by 3 plus c, okay? And then you can re-put whatever is there, the value of t, and answer, you can get the answer. Second thing was you just means open the formula for sine cube theta as your 3 by 4 sine theta minus 1 by 4 sine 3 theta, okay? Use the formula for sine 3 theta and then put sine cube theta as, change it as, because theta here is your 2x plus 1, so you can change it like this. So it becomes 3 by 4 sine 2x plus 1 minus 1 by 4 sine 6x plus 3, okay? So now take 3 by 4 outside, it becomes sine 2x plus 1, and it is minus 1 by 4 sine 6x plus 3, which sine is, integral of sine is minus cos 2x plus 1, and t dx of 2x plus 1 is 2, divided by it, minus 1 by 4, it becomes your minus cos 6x plus 3, and you have to divide by 6 also. Now open all the terms and you will get the answer, right? So similarly for the second part, this after substitution of the value of t, you will get the answer like this, right? Number 5 is sine cube x cos cube x. Now you see here both are having same power, okay? So you can bring them like this, sine x cos x raised to power 3. Now again I can change by multiplying, divide by 2 inside, you can change it as sine 2x, so it becomes sine 2x whole cube. So again sine cube 2x can be again opened by this formula, right? As we opened for your sine cube x, the formula can be opened, right? Okay, or otherwise the same way you can put sine x as t and then cos x dx, or you can also put cos x as t, right? So whatever you will get that the form of answer given in NCERT book can be obtained by using putting cos x equal to 2, means the way the answer has been given, because you will be getting two different answers, right? So let us focus on our this part, that you can just now integrate sine 2x as your minus cos 2x upon 2, right? And this 3 by 32 is there, and this is minus 1 upon 8 4s are 32, and sine 6x is your minus cos 6x upon 6 plus c, and which on opening the terms we can get like this. So this question can also be done by your putting sine x or cos x as t, right? But if you want to get the answer like NCERT book, so you have to put cos x. Now to integrate sine x, sine 2x, sine 3x, as like we did for cos, we will take multiply and divide by 2, take sine 3x and sine 2x, means association we need that the angle, when we are applying this formula like a plus b and e minus b, avoid fractional powers, okay? Fractional terms, fractional angles, right? So like we will apply first for 3x and 2x, so it becomes your it is 2 ss is for cos a minus b minus cos a plus b, right? Otherwise we know c minus c is minus 2 ss, okay? 2 ss. So to balance that negative sign, let's take cos a minus b first and minus cos a plus b second. So it becomes cos 3x minus 2x minus cos 3x plus 2x and into sin x outside. So it becomes your cos x, and this is sin x, right? Cos x minus cos 5x into this. So after opening it becomes cos x sin x minus cos 5x sin x. So again you have to multiply and divide by 2. So this is your sin 2x, the formula for 2 sin a cos b, 2 sin a cos a, right? And it is your second one is you have to apply now the formula for 2 cos sine, that is s minus s. So it becomes your, for second part, sine, your angle is 5 and this is it. It is 5x plus x minus 5x minus x. So it becomes sine 2x minus sine 6x plus sine 4x, right? Okay, so that means this integral is converted to this form. Now we can integrate like sine 2x is your minus cos 2x upon 2, sine 4x is minus cos 4x upon 4 plus cos 6 upon 6, right? Plus c. Now be careful that the integral of sine is minus cos. Okay. Next is sine 4x, sine 8x. Now it is very simple, as we did it for three trigonometric functions multiplied. So here just 2 are there, so I'll go for multiply and divide by 2. Means that once it should be in your mind that in such questions you have to firstly multiply and divide by 2. Okay. Now the formula is for this is 2 sine means cos a minus b minus cos a plus b. So it becomes cos a minus b minus cos a plus b. Now why we took, means otherwise we would have taken 8x first and 4x second, because cos is an even function, so it doesn't affect, right? So because this cos minus 4x will be your cos 4x, and this becomes minus 12x, right? So this is means cos 12x. So this minus is not affecting, that's why we didn't bothered about taking this 8x first and 4x afterwards. Okay, otherwise we will do the rearrangement as required if some other function is there. So cos 4x is your sine 4x upon 4, and it is minus sine 12x upon 12 plus c, and open the terms and you will get the answer. Number 8 is 1 minus cos x upon 1 plus cos x. Now you can proceed by rationalization, but the simple way to suggest is use that formula of 1 minus cos 2 theta is 2 sine square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. Okay, it will change to tan square theta. Okay, tan square theta by 2, right? And tan square is to be integrated only by opening secant square theta minus 1. Now secant square theta by 2 will be your tan theta by 2, and you have to divide by derivative of x by 2, that is half. So it becomes, and your 1 is your integral is minus x plus c. So it becomes 2 tan x by 2 minus x. Number 9 is your cos x upon 1 plus cos x. Okay, so this question also you can proceed by rationalization also, but if you will make means denominator like, so this is also one other way, that add and subtract 1, separate the numerator, see it becomes your 1 minus 1 upon say 1 plus cos x. Okay, so 1 plus cos x can again be changed by that formula 2 cos square x by 2, so that it changes to integral 1 minus half secant square x by 2. So integral of this is x, and this is your tan x by 2 upon half plus c. So x minus tan x by 2 plus c. Integral 4x. Now how to integrate 4x? For 4x you will go by, like for sine and cos, same patterns are followed. So sine raised to power 4x can be opened as sine square x whole square. So sine square is to be integrated by using the formula 1 minus cos 2x by 2. So its whole square you have to take in this case. So now open it is 1 plus cos square 2x, a minus b whole square we are applying, minus 2 cos 2x. Now again cos square 2x is there. So cos square is there, you have to again use the formula like 1 plus cos 4x upon 2. Okay, so again this formula is to be used, because whenever sine square and cos square is there, you have to use this formula. Now everybody has now, I think, is free from powers. Now term, like take the LCM and open all the terms, so you will get here 1 by 8 times 3 plus cos 4x minus 4 cos 2x. So it is 3 times 1 dx plus cos 4x integral minus 4 cos 2x. Okay, so it becomes 3x plus sine 4x upon 4 minus 4 sine 2x upon 2. Okay, and open and multiply by 8 and you will get the answer. Similarly for cos raised to power 4 2x, again we will go for like your cos square 2x whole square. Okay, so again I use change it by 1 plus cos 4x by 2 whole square. Okay, now again open by a plus b whole square. Again, as cos square is appearing, I will again use this formula to change. Okay, and then we can open it again, and the same way the question can be integrated. Sine square x upon 1 plus cos x. Now simple way is to open this sine square as 1 minus cos square x. Change it to a plus b into a minus b. This changes cancelled by this. This is 1 minus cos x. Integral of 1 is x, and cos x is sin x, and this becomes x minus sin x plus c. Number 13 is cos 2x minus cos 2 alpha upon cos x minus cos alpha. Now again you see that 2x can be changed as 2 cos square x minus 1 minus this can be changed as 2 cos square alpha minus 1. Right, now this minus 1 and 1 will balance, and taking 2 common I'll get it as cos square x minus cos square alpha in the numerator, and denominator is same. Right, now use a plus b into a minus b here. See, right, so what happens, this changes
And now this is simple to integrate. Cos x, integral of cos x is your sin x, and this 2. Now cos alpha is constant, remember one thing, because this is we are integrating with respect to x. So cos alpha is there, so it is 1 dx, which is your 2 times sin x plus cos alpha into x. Okay, integral of 1 is x plus c. So this is the required answer. Now cos x minus sin x upon 1 plus sin 2x. Okay, now for this, you should remember that how to open it. We have to open it like your 1 as sin cos square x plus sin square x, and this it is 2 sin a cos b, so that denominator becomes cos x plus sin x whole square. Now put, that this numerator is the derivative of this, so put cos x plus sin x equal to t, so that cos x minus sin x dx equal to dt, so it becomes dt upon t square. So how to integrate? Take it to t raised to power minus 2 dt, and by power rule, t raised to power minus 1 upon minus 1 plus c, so it is minus 1 upon t, that is minus 1 upon cos x plus sin x plus c. Now when tan and secant are together, you know that if I put tan x as t, so you need secant square as derivative, so it is not possible for me. So I think I should search for something else. So what will I do? I'll open it as, means, and if I'll put secant x as t, then I need secant x tan x. Okay, because the derivative of it I need. So I'll open tan cube as tan square x. Remember, tan square 2x and tan 2x and secant 2x. Okay, now open this tan square 2x by using secant square 2x minus 1, and this is your together. Now what I will do is I will just put my secant 2x as t. Why? Because the derivative of secant 2x is present here. Okay? So what is the derivative of the secant x? Secant x is secant x tan x. Okay, and then your ddx of 2x is 2, right? So it will become your, means when I'll find the value of this becomes dt by 2. So it is half. Okay, it becomes half of t square minus 1 and dt. Okay, see, half of, because this becomes dt. Okay, half t square minus 1 dt. So it is half t square is t cube by 3, and it is minus t plus c. Now put the value of secant t as secant 2x, and you'll get the answer. Tan 4 is to be integrated like, it can be integrated in many ways, but let's see, means instead of going for tan square into tan square whole square, it's better to change it to tan square into tan square. Change 1 of tan square to secant square. Now open this integral, it becomes tan square secant square minus tan square x. Now tan square secant square x dx minus tan square x. Now you know the how to integrate this tan square x. It is to be integrated like secant square x minus 1, and this tan square secant square x, you have to do the substitution. Now you know that the derivative of your tan x is secant square x. So here I'll go for substitution as we did in 7.2, right? So for this integral, I'll put tan x at t, so that secant square x dx is dt, and this question changes to t square dt. Look here, and this I'll open now, minus secant square x dx plus 1. So integral of secant square x is minus tan x, and 1 is x plus c. Okay, integral of t square is t cube by 3 minus tan x plus x plus c. Now put t as tan x, and you'll get the answer. Number 17 is sin cube x plus cos cube x upon sin square x cos square x. Okay, now you need to break up the numerator. Okay, split it. So break the terms sin cube x upon sin square x cos square x plus cos cube x upon sin square x cos square x dx. Okay, so you just one sin square is cancelled with this, so means after opening and reducing, I'll get it as this first term as tan x secant x, and second as cot x cosecant x. Now secant x tan x has integral secant x, and cosecant x cot x is having minus cosecant x plus c, which is the required answer. Number 18 is cos 2x plus 2 sin square x upon cos square x. Now see, this cos 2x can be opened in many ways, like 2 cos square x minus 1, 1 minus 2 sin square x, or cos square x minus sin square x, right? But here the most suitable one is to change it to 1 minus 2 sin square x. Why? Because it will help in reducing my numerator, and it just has 1 and 1 upon cos square x it becomes, which can be changed to secant square x, and the integral is tan x plus c. Now you have to integrate question number 19 to 22. And an important note is here concerning with the next question, that method to evaluate the integral like 1 upon sine raised to power px into cos raised to power qx, means both sine and cos are there in multiplication in the denominator with different powers. Okay, with different powers. Now what can we do? We will add up the powers, right? So which is a negative even integer, right? Which will be a negative even integer, say minus n, right? Why negative? Because they are in the denominator. Then I need to multiply in denominator and numerator by my secant raised to power this n. Okay, secant raised to power this n x. Okay, and see how it is applicable in number. Number 19 is 1 upon sine x cos cube x, right? So sine, it is of the form of 1 upon sine raised to power px and cos raised to power qx, right? So here p plus q means the power of this p is minus 1, right? Because it is in the denominator, so it is minus 1. This is minus 3, which is minus 4, which is negative even integer. So as per the previous note, I have to multiply divide by secant raised to power 4x. Or I can decide that, see it is 1 upon sine and cos are in multiplication with different powers. So I will divide and multiply with power of cos one more than generally of this cos power, right? Like I have to divide numerator and denominator by 1 upon say cos 4x both, right? So that the question changes to my secant and tan form, right? So that way also, like 1 upon cos 4x will also give me secant 4x, and this denominator will also reduce to tan x. Okay, now the next thing is I'll change this secant 4 to secant square x into secant square x, and open 1 upon secant square as 1 plus tan square, right? And the question just changes to tan and secant. Now I can substitute tan x as d, secant square x dx is dt. It changes to 1 plus t square upon t dt. So open it, take the numerator 1 upon t plus t square by t dt. So it is 1 upon t, integral 1 upon t dt plus integral t dt. 1 upon t is log mod t, it is t square by 2 plus c. Put t as tan x, it is log mod tan x plus half tan square x plus c, right? Now 20 is cos 2x upon cos x plus sin x whole square. Now see, cos 2x can be opened as 2 cos square x minus 1, 1 minus 2 sin square x, and also cos square x minus sin square x, which is the most suitable for this question. Why? Because you know, if you change cos 2x to this, you can open like e plus p into e minus p, right? One of it changes, and now it is, if you put the denominator as t, the derivative is your denominator and changes to dt by t, which is log mod t and log mod cos x plus sin x plus c. Or we can see that it is of the form of integral f dash x upon fx dx, whose integral is your log mod fx plus c. Then is sine inverse cos x. Okay, so sine inverse cos x, how to go for this question, right? That we know that cos, you know, the rule for inverse trigonometric functions, I need to get rid of this sine inverse. So I change cos to sine 90 minus theta. So sine and sine inverse will vanish, and I'll just get pi by 2 minus x. Now pi by 2 is constant, so it is pi by 2 times 1 dx, and it is your minus x. Okay, so it is pi by 2 x minus x square by 2 plus. Now number 22 is 1 upon cos x minus a, cos x minus b. So there are also 4 type of questions, right? One is 1 upon cos x minus a, cos x minus b, 1 upon sin x minus a, sin x minus b, 1 upon cos x minus a, sin x minus b, 1 upon sin x minus a, cos x minus b, right? Now there is a methodology how to execute such questions. Now see, as you can see that it is 1 upon cos. Okay, means you look at the equation, you'll observe that both the numerator is having 1 and denominator is having your both cos. Okay, so see how we execute this question. Like can I write x minus c minus x minus b? Okay, now this is there, right? So if I open it x minus a minus x minus b, it is just p minus a, right? So what will we do? We will multiply by and divide by sine b minus a. Okay, now why we did so? because this is again you can see the numerator is very small and the denominator is heavier. So I want to bring things to numerator, right? So sine b minus c we took, right? Which can now, because this terms will not be cancelled, because we need something like angles like x in the form of x minus c at x minus b. So what we will do, we will b minus c can be written as your x minus c and x minus b, right? So it can be written as sine of x minus c minus x minus b. Now it becomes your sine a minus b. I use the formula for sine a minus b, that is sine a cos b minus cos a sine b, right? Now again break the numerator, means separate the terms as we did for the earlier questions, okay? So it becomes sine x minus a cos x minus b upon cos x minus a cos x minus b minus cos x minus c sine x minus b upon cos x minus a cos x minus b, right? So it becomes your, you can see that this gets cancelled. Now here this gets cancelled. So it is tan x minus a minus tan x minus b. And this is all together running like this, okay? Now what is the integral of tan? Tan is your minus log mod cos. So it is minus log mod cos x minus a, right? So ddx of x minus a is 1, so means it is just like this. And this one is your again minus log mod cos x minus b, but minus of minus is plus, right? Now we are going to use the formula for log a minus log b, okay? That is log a minus log b is log a upon b. So it is your log x minus b upon log x minus a, and 1 upon sine b minus a log cos mod cos of x minus b upon cos x minus a whole mod plus c, right? So whenever you are having like in the denominator both either terms of cos or both terms of sine, you will multiply and divide by sine b minus a. And if one out of this is cos and one is sine, either it is first cos second sine or first sine then cos, you will multiply and divide by cos b minus a, okay? And this way such kind of questions can be executed. Choose the correct answer in question number 23 and 24. 23 is sine square x minus cos square x upon sine square x cos square x dx. You have to choose out of these 4 options. Now see, it is very clear as that question of sine cube and minus cos cube we did, that it's better to break the numerator, means separate the terms. So when you will, it will be sine square x upon sine square x cos square x minus cos square x upon sine square x cos square x. So it becomes your 1 upon cos square minus 1 upon sine square, right? So which is your secant square x minus cosecant square x. Now the integral of secant square x tan x and cosecant square x is minus cot x. So it becomes minus n and minus plus cot x plus c. So option number E is my correct answer.
Question number 24. Integral e raised to power x 1 plus x upon cos square e raised to power x into x dx. You have to search out which of the options is correct, okay? Now this question is based upon the substitution, and again the thing which is means you should search for the function and its derivative. So you see that if I'll put your e raised to power x into x as t, right? So we can differentiate it like the derivative of it will be done as you do for product rule, right? So it is your function into derivative type of thing. So that means it will become your e raised to power x into 1 plus your x into e raised to power x, right? This is equal to dt by dx. That is, take e raised to power x common. So it is e raised to power x times 1 plus x dx equal to dt. So see, this question changes to your dt because this numerator is equal to dt. So it is dt upon cos square t, which is your secant square t, and you know the integral of secant square is tan t. So it becomes tan t plus c. Now resubstitute t as x e raised to power x plus c, and your option number B is the correct answer. So this was all regarding your solutions of exercise 7.3, which was based upon use of trigonometric identities. I hope whatever is done is clear to you. Thank you so much.